All right, so here we go. Raise your hand if you use Python. I'm sure that's everyone in the room, right? Then raise your hand if you use WhatsApp for Windows. All right, perfect. I'm speaking to the right crowd. So basically, if you use WhatsApp for Windows, I can send you a file, and when you click open, it'll execute. So I could delete system 32, I could corrupt your files. So yeah, scary business. I know. So if you think you're a Mac user, if you're a Mac user and you think you're better, you're not. You're not. So my name is Nunudzai, and the title of this talk will be Silent Clicks and Loud Consequences. So I've always been fascinated and passionate about cybersecurity, right? So I work in cybersecurity, so I'm like a hacker, as you can see here. And the one thing I love about software or cybersecurity is that I love to learn from technology when it works and when it doesn't. Because my goal is to replicate this, right? Is to replicate those errors and those problems. So our journey begins last year. This is July of 2024. A news article came out. So basically, if you send a well-crafted Python file on WhatsApp for Windows and you click open, it will execute. No warning, no nothing. So I was reading about this story in December, and I said, okay, what type of Python files? It's not just any Python file, right? So it's a PyZ and a PyZW. So these are not your ordinary or your common Python files. So these are compressed Python files, right? So the difference in execution is that if you send a PyZ, you see this for a split second, right? But if you send a PyZW, there is no noticeable background activity. And that's scary. That is some scary business. So the story came out in July. I discovered it in December, and in January, I was excited. I was super excited because it meant one thing: experiments. So when a vulnerability is disclosed, right, the company usually has a plan to patch it, right? But according to the security researcher and the statement from WhatsApp, they said, hey, users shouldn't be clicking on random files anyway. So yeah, so it's not our fault, and we're not going to fix it. So that's why I was excited. I said, okay, let me think like a hacker. What would a hacker do? So, three main goals: steal information, control your computer, your device, or cause mayhem. So I said, okay, let me find a way to steal passwords, to steal your banking information. Let me find a way to control your computer. I send you a file, I spy on you via the camera, right? Let me corrupt your files, let me delete your files, right? Basically, let me be a nuisance as an attacker just by sending you a file. So I made some code. Oh, by the way, I'll share the code, but the code has one problem. It's made to be very destructive, right? So I'll share it with you. I don't take any responsibility if like your computer is locked because that's the whole point. That's the whole point. So I'll share my code, but fair warning, it will cause problems. So some of the code I wrote. Okay, so the first phase of hacking is you gotta do reconnaissance. That's a fancy way of saying I need to gather information, right? So if I'm gonna steal from you, I need to know your routine. I need to know where you live. I need to have information so that I plan around that. So I could send a file and it would tell me basically all the information, right? Your operating system, the name of the computer, your architecture, host name, IP address, the on your drives, how many drives you have, how much storage you're using, like just all of that, right? Then I said, let me try and manipulate some files. So we're talking about deleting files, we're talking about editing files, we're talking about creating files. And I got lazy and I made AI write some code, and it's not the best, but it gets the job done. You know, it really gets the job done. So in the worst case scenario, if you're very careless and you don't have a backup, and I just say, OS don't remove your files, they will be deleted permanently. And there's no record of, oh, where did these files go, right? So let's up the ante a little bit, right? Let's corrupt some files, because I find that corrupting files is very easy, especially PDF files and doc files, because they're they're like a chain, basically. And a chain is only as strong as its weakest link. So I made a diagram here to explain the structure of a PDF file, right? So the head is the version number, the body is the objects, which is the stuff we see, then the cross-reference table and the trailer. So basically, each section of the PDF talks to the next section. So the cross-reference table says, okay, on page 2 we have a picture, on page 3 we have this, and the trailer says, okay, here is all the information. So if I corrupt the header, it doesn't matter whether this information is accurate or not. If the current version is version 6 and I put version 6 million, it's corrupted. You can't open it, right? So basically, you could just add an incorrect version header. You could put pictures that don't open. You could reference a page that doesn't even exist, a 3-page document, but you reference page like 6, right? Small little things, just to cause errors. Just to cause errors. So I made a reverse shell, and I was really proud of myself, because in the cybersecurity community, if you make a reverse shell, it's basically like your computer is logging onto the attacker's computer, right? It's saying, hey, I'm going to make a connection to this. So if you have a firewall, if you have an antivirus, and you're making a connection to me, it's assumed that it's a safe connection, right? So a reverse shell or a reverse TCP connection is the best way to control someone's computer. However, there's a problem. Let's say I get a reverse shell on your computer, but you're a guest user. So because you're a guest user, I don't have as much permissions as an admin, right? Or maybe you have multiple accounts, or maybe there's some authentication. So it works based on the user that's logged in at the moment. Now, all the code I wrote involved a level of stealth, because the antiviruses I tested, they never complained. There was no issue of, hey, warning. Nope, it was fine, right? I even looked for a website where you can upload malware or code and see if a bunch of antiviruses will see if it's malicious. So I uploaded it onto VirusTotal, and nothing. You know, even though it's a file that's made, a Python file that's made to do destructive behavior, it was not flagged, which I find very weird, to be honest. Very weird, because the way these engines work is that they should just read through the code and try to simulate what the code is trying to do. So things got a little bit weird, right? Just like any experiment, there are things that don't go according to plan. So my dream was to make either ransomware or like a piece of code, a malware called a keylogger. So the way ransomware works is you just see a screen on your computer and it says send Bitcoin to this address, blah, blah, blah. Your keyboard, your mouse is not working. You can turn it off or on, but it's just that, right? So I tried that and it didn't work. Okay, so then I tried a keylogger. So I split the keylogger into 3 different functions or phases. So the first one, so the way keylogger works is that it records every single key press. Your space bar, your up, your down, every single, right? So it'll record your keystrokes, then store them somewhere, then send your data to like a paste bin or some specific website, right? So I tried that, and it didn't work, right? But I can still, the reverse TCP connection works. I can connect to the person's computer, but it's not sending data, which made no sense honestly. Like if step A works, but step B doesn't work, like what's going on, right? And then I found a really big limited execution well, environment, I would say, right? So the way the execution works is that when I send the file to you on WhatsApp and you click open, WhatsApp kind of passes that to Windows, right? Because WhatsApp says this is a Python file. Windows do your job. Then Windows says, okay, what is the default application associated with this file? Then Windows says, oh, it's python.exe. And what .exe files do they execute? So there is something wrong happening because when you're clicking open, but the code is being executed. So Uncle Ben once told Spider-Man that with great power comes great responsibility, right? I'm sure we all know this. But in our case, who's responsible, right? Should WhatsApp be giving people warnings? Should Windows be blocking this? Is it the fault of the antivirus? Like I couldn't sleep because I kept thinking about this. And another caveat or problem is that I try to go to journalists to say, hey, look, there's this issue, it was reported months ago, it's not fixed. And they say, okay, does it work on a default installation of Windows? No. So it's not going to make a good headline. So immediately the story is kind of dropped. Reason number two, it affects a small subset of a small subset of a small subset of a population, right? But if you go to a PyCon conference, we all use Python, right? We are all beginners at some point. So does that mean we are insignificant, right? So I just kept asking myself all these questions, and it's something I would love to have a conversation about with when we or you as a developer or as a tech company, when you make a product and you just say, hey, user, don't click this. Are you really doing it? Are you really delivering a good product to your users? Are you really caring about your users, right? Who would be responsible now? Because if you go on the internet, there are a lot of different takes when it comes to these vulnerabilities, right? Like if one click can destroy everything, the problem isn't the user, it's the system. But when this vulnerability spans across systems, then which system is to blame, right? So I made a couple fixes. Of course, for a user, the most basic one is, yeah, don't open, these attachments, right? But if I'm like, if if internet is tight and I use WhatsApp, I'll say, hey man, can you just run this code? So I said, okay, imagine it's you and me, we're working on a project and I'm just sending these files by WhatsApp and my account is taken over and you're used to us sending each other Python files. And one day my account is now a sock puppet account and it sends you a code that just deletes your system, then like how do you recover from there? You know? For Windows, I would think it would be a good option to warn people. Say, hey, the file you clicked open will execute. Are you sure? Like I remember for PDFs on, I think it was mainly on my phone, it gave me an annoying warning like, hey, are you sure you want to open this? But it's a PDF. But if we could do that to these extensions as well, it will just give a bit more, warning to the users and limit the attack surface. And for AV or antivirus tools or any security tool, it would be good to include um, malicious lines of code, right? Be it in Python or in these niche extensions as well. So, what did we learn? Honestly, I hope we learned a lot. But in my opinion, the problem wasn't that the file was executed, right? It's not because, oh yeah, the code was executed. It's because the problem is that there was trust from WhatsApp for Windows, the antivirus, and Windows itself. So if we're going to be making code where we just trust users, it's not the best because for Telegram, they had a similar vulnerability. Of course, it was caused by a typo in the source code, but it was a similar vulnerability where you send a Python file, you click open, and the code is run. So And the funny thing is, this happened a few months earlier before this vulnerability was closed for app. So I don't know what it's gonna take to convince the creators to fix this, right? Maybe it has to be exploited more, or there have to be more apps that have the similar vulnerability. I don't know. I really don't know. But trust can be dangerous, and this vulnerability is still unpatched. I can show a couple demos. Hopefully, I don't break my computer inadvertently, but we'll do that. And there have to be better trust chains between, different applications, especially when data or files are being sent from one source to another. And awareness and mitigation are critical. So as I'm telling everyone this, don't go hacking people, please. I don't want to be seeing you on the news. So thanks for listening. Thanks for listening. So whilst you're thinking of questions, I can do a short demo. Let me just disconnect my screen. Sorry, what? Did you say something? Okay, so I got some code here just to demonstrate what I said. So I have some code. So I have some code that will just open the calculator. So I got 3 files. So for the Python file, if you click open, nothing happened. So yes, this is good. So usually it should say sending failed. Yeah, right there. Save failed. So that's good. For the PyZ, for a split second, the CMD will run, but it'll close. You open the calculator. Then with this one, there's no noticeable background activity, and boom, there we are. So do with that what you will. And if you guys have any ideas of any like other exploits you want me to write, I'm all ears. Yeah, so questions.
Hi. Nice talk. Did you try downloading your keylogger and putting it in auto startup files?
I do not actually, because how I was testing it is like, imagine just you and me and we're having a conversation and I send you the file and you click open. That's the environmental use case I was thinking of, like the most basic one. However, that sounds interesting and something I could definitely try and see. So yeah. You have a question? Oh, uh, thanks for that. I actually need to clarify something. So another guy, another security researcher based in India, he discovered it. So when I was reading about the story and I asked him, "Hey, this thing hasn't been patched," and he said, "Oh yeah, I know, and I don't expect them to do anything about it." Right. So I was also working with him a little bit just to make some more proofs of concept or more code to show how dangerous this is, and he did open the case many times in the bug bounty program, but he was just ignored. Like, hey, this is useless. This just yeah. So oh, okay.
Okay, if this only affects, say, Windows machines, right? Is it possible that the argument that Meta would have or Windows would have is to say, okay, by default, they don't serve Windows with Python pre-installed, right? And then, secondly, I noticed that when you download the .py file or the .pyz file, it executes for a second. Is it possible that in the script, console, like the bash will Bash would read that would read the code, right? But then it gets to a point where it meets a bash command that calls it off. Isn't that a preventative measure in a way? O- Okay, all right. The reason why I'm asking that is because I've seen this thing where if you want to like run a script that runs in the background such that the user doesn't see what you are doing, right? Like I once had this piece of code that would retrieve particular files from a machine, right? And then I didn't want the user to be spooked by seeing activity from the terminal, right? So I wanted the whole thing to be running in the background. But isn't the fact that there is a pop-up a good thing?
I mean, to some extent, yes, because when you're using a Windows machine, command prompt shouldn't just pop up and close. So, in the sense of your question, yes, it's a good thing for a user, like when they see that, oh, there's some background activity happening, something suspicious. Yeah, I guess it's a good thing. Then for your other question, could you repeat your first question? Yeah, more questions, more questions. Keep them coming.
Maybe hopefully it's the last one. You do mention trust is very dangerous, which it is. I agree with that. But then how do you then to some extent control that? I mean, we do click stuff, eh? As users. Also, I do love the freedom of having to be given a laptop and then I install whatever, all of those things. How would you then mitigate such incidents?
I can answer that. So, when I started learning cybersecurity and about vulnerabilities, there was this rule of never trust user input, right? In forms, always validate user input and so on. But when it comes to a laptop, something that's more complex, it's not just a form. You can download file, you can execute code. There's no one answer, one solution. Like have an antivirus, right? Or have this, or have that. I think it's more of a kind of using like buzz terms here, but it's more of a principle of zero trust. Of like, yes, you want to execute this. Are you sure? Yes, you want to run this. Are you sure? It's more of having mechanisms that can verify the actions you want to do, right? That way, you don't just inadvertently run something dangerous, right? It gets verified by a couple of levels and a couple of checks. So that's one way. But of course, there's no one perfect solution.
How come this doesn't work in a browser? Like, because I feel in browsers you can at the same time open and play things. So do browsers have natural more protection? Like, do apps just have higher levels of permission? Like,
That's a good question, actually. So there are two reasons. There's a simple reason, right, which is how the file gets executed, right? Because according to the interaction between WhatsApp and Windows, is that if you see a file with the extensions mentioned, look for the default application to open it and just run it, right? It's just like that. However, in a browser, depending on what software you have, it can be sandboxed, or if it can be flagged by your antivirus. And also with a browser, when you click open, it does exactly that. Like when you click save, it does exactly that. But in this case, open is not open. Open is just run immediately. Yeah. All right. Thanks, guys.